Hello students, welcome to this class. Today we will be studying about what experimental designs are. Before we actually begin the topic, let us imagine the field of architecture. Before building any kind of house or building, what do? We make a blueprint or a plan of the house. And when we come to the context of an experiment, the research design or the experimental design, it's nothing but the blueprint of an experiment. It is a detailed step-by-step plan on how data should be collected and the hypothesis should be tested so as to answer our questions regarding the research. Now there are certain criteria for research design. The first criteria is that the research design should be adequate, or in other words, the research design must be sufficient to answer the research question. For example, if we want to know the interaction of two or more variables, then it would be most useful to use a factorial design instead of a two-group randomized design. A two-group randomized design here would be an inadequate design. Now what these designs are, we will be learning later in the lesson. A second criteria of a research design is that it should be objective, or it should provide an accurate result regarding the research questions we are trying to answer through the experiment. A third criteria of the research design is that it should be valid, or it should measure what it seeks to measure. Say for example, we are trying to measure the level of intelligence, then of course the research design should also measure the level of intelligence. If not, it will not be valid. And if a research design is valid, automatically it becomes generalizable, or we can use the results of the research and apply it to the general population. A fourth criteria and a very important criteria of the research design is that it should be economically possible or economically feasible. If you make a very elaborate and sophisticated and high-end design and do not have the funds to actually put the design into practice, then the research design becomes of no use. Finally, a research design must be able to control both extraneous variable effects and error variance. Now, extraneous variables are those variables in an experiment that have an effect on the dependent variable apart from the effect of the independent variable. But the fact is that we want to isolate only the effects of the independent variable on the dependent variable. Hence, to avoid confusion of results, it is extremely essential that all the extraneous variables must be controlled, and a research design must allow for such control. A second kind of variance is error variance. This may be something usually beyond the control of the experimenter, such as the attitudes, values, or temporary mood fluctuations in the subject, or the usual fluctuations that happen from one condition of the experiment to the other. Now, a research design must be so constructed that the error variance should be reduced to the maximum possible extent and a greater degree of control should be exercised. According to Ossel and Mensing, there are three basic principles in any kind of research design. The first is replication. Replication involves repeating the same experiment using the same design but with different subjects and at a different point of time. Now, what replication does is to tell us whether an experiment is reliable or whether when the experiment is repeated a certain number of times with different subjects, the same results are obtained or not. So, a research design, if it is effective, must allow for replication, and through several replications, the same or accurate results must be obtained. A second important criteria of a research design is that it should allow for randomization, or it should allow for a random selection of the sample from the population and a random allocation of the sample to the control group and the experimental group. Now, although this is what we always look for in an experiment, in behavioral sciences, when we deal with individual differences and a number of subject-relevant variables, a complete randomization may not be possible, and hence the experimenter should not be very rigid that I always want a complete randomization. He should seek a middle path between a total absence of randomization and complete randomization, somewhere where he can use at least some extent of random control. Third aspect of the research design according to Ossel and Mensing is that it should allow for local control. There are three aspects of local control. One is grouping, the second is blocking, and the third is balancing. Now, grouping and blocking involve assigning subjects to different groups or blocks so that the subjects within each group or within each block are homogeneous, and hence they can easily be divided into the control group and the experimental group. Balancing involves doing grouping and blocking in such a way that the entire design of the experiment remains balanced. Thus, we know that the experimental design is something which actually guides the experimenter throughout the process of the experiment. It organizes the entire theme of the experiment. And going into an experiment without an experimental or research design is something like trying to build a house without having any plan of how many rooms you will be having or what will be the entire blueprint of the house. So as we know, experimental designs are extremely essential and should be clearly formulated before the start of the experiment. And today we will be dealing with some important kinds of experimental designs. Now I want you to have a look on the slide in front of you. You can see how the different experimental designs are divided. We see that the main division in experimental designs is between the between subjects design and the within subjects design. The within subjects design, as you can see, is divided into complete within subjects design and an incomplete within subjects design. On the other hand, the between subject designs are divided into three types. The first is the randomized group designs, the second is the matched group design, and the third is the factorial design. And again, you can see that the randomized group designs are further divided into two types, that is the two randomized group designs and the more than two randomized group designs. Now, although we use between subjects design as also within subjects design in experimental research, the former or the between subjects design is more frequently used. So first we will be dealing with the between subjects design, and in that the first type or the randomized group design. As I already mentioned, the first type within the randomized group design is the two randomized group design. Now the two randomized group design is a simple design. Here the experimenter selects an independent variable and a dependent variable, and he manipulates the independent variable in two ways so that two groups of subjects are formed. And he wants to know whether this manipulation of the independent variable in two ways will have any kind of differential effect on the dependent variable. For example, he will select an independent variable reward and a dependent variable learning. So he wants to know the effect of reward on learning. And reward he can manipulate in two ways. First, he can constitute a reward group which receives a reward on learning a certain sequence, and a no reward group which does not receive a reward on learning some particular material. So what an experimenter will do is to first determine his population, say for example 500 students, and from these 500 students he may randomly draw 100 students to constitute his sample, and randomly he will divide these 100 students into the two groups, 50 students into the reward group and 50 students into the no reward group. So this is the basic two randomized group design, where subjects are randomly divided into two groups or two manipulations of the independent variable. Now a basic aspect in the randomized group design is randomization, or the process of randomly dividing subjects into various groups. And randomization can be undertaken in two forms. One is captive assignment and the other is sequential assignment. Now these two processes hold true for all types of randomized group designs. In captive assignment, the experimenter has an entire list of subjects, and all the subjects are present before the experimenter during the course of division into the control group or the experimental group. And hence, he may use a number of techniques to divide them. He may number them, say 50 students into 1 to 50, and put all the chits in a bowl and pick out random chits. The first chit picked out goes into group A or the control group, the second chit picked out goes into group B or the experimental group, and so on. Another technique that the experimenter may use in the process of captive assignment is the table of random numbers. He may move horizontally, vertically, or in any direction throughout the table to get a sequence, say 3, 6, 4, 2, 1, 2. And he will concentrate only on the ones and the twos. So if the first number in the sequence 2, 1, 2 is 2, then the first subject goes to the second group or the experimental group, and the second subject goes to the first group. The third subject, again the number is 2, goes to the second group, and so on. Another technique is that he may arrange the list of subjects alphabetically. And the first subject goes into the first group, the second into the second group, the third into the first group, and so on. So as we can see, there are different methods of captive assignment. A second method of assignment is sequential assignment. Now, a second form of assignment is sequential assignment. When the experimenter doesn't have the full details of the subjects participating in the experiment, he only knows that a certain number of subjects will be participating and the experiment may actually go on for a number of days. So how will he go about the random assignment? Say for example, there are 50 subjects and there are 5 conditions of the experiment, as you can see in the slide A, B, C, D and E. He will divide the subjects into 5 groups and he will make 50 chits. 10 chits will have A written on them, 10 B, 10 C, 10 D and 10 E. And then he will pick out the chits in any random fashion. So he may get a sequence such as C, C, A, B, B, A, D, E, E, D and so on, as you can see in the slide. And then the first subject who comes will go into group C or the treatment C. The second subject also to the treatment C. The third subject will go to treatment A. The fourth to treatment B, the fifth to treatment B, and so on. So some form of random assignment is made. A second form of sequential random assignment would be block randomization. Here, since the experimenter knows that there are 5 conditions of the experiment, he will create blocks containing these 5 conditions but in different sequences. Say for example, the first block may be C, A, B, D, E, so that the first subject goes to treatment C, the second to A, the third to B, the fourth to D and the fifth to E. And again you can see there is a different sequence in the next block, B, D, A, E, C and so on. So block randomization and complete randomization allow the experimenter to apply the randomization process even though all the subjects are not present during the actual process of randomization. Now the two-group randomized designs have certain disadvantages. Say for example, there is a loss of subjects, a high number of subjects, say 5 to 6 out of a sample of 50. It immediately raises questions regarding the experiment as to whether the subjects were originally the part of that original unbiased group, or whether there were some procedures wrong in the experiment, whether the subjects developed some kind of bias or negativity towards the experiment, whether the tasks were too difficult or too boring, and so on. Another difficulty while applying a two-group randomized design is that we are not able to understand in detail the relationship between the independent variable and the dependent variable. In an experiment, there are 2 aims. First, to find out whether there is a relationship between the independent variable and the dependent variable, and second, to find out what is the nature of the relationship between the independent variable and the dependent variable. The first question is answered in a two-group randomized design. For instance, we know that reward impacts learning. However, we do not know, for instance, whether a monetary reward or a reward in the form of appreciation better influences learning, because this would involve more than 2 manipulations of the independent variable, which is not possible in a two-group randomized design. A second type of randomized design is the more than 2-group randomized design. Now this in many ways is a more effective design than the two-group randomized design, because here we can use more than 2 manipulations of the independent variable. Say for example, we want to know the efficacy of 4 teaching methods, teaching method A, teaching method B, teaching method C and teaching method D on student achievement. Then it is best to use a more than 2-group randomized design because it allows for more than 2 manipulations of the independent variable. If we were going to use a 2-group randomized design in this condition, then we would actually have to make nearly 6 assessments. That is, compare teaching method A with B, then A with C, A with D, then B with C, B with D, and then finally C with D. So you know the amount of complication that is involved. Thus, the more than 2-group randomized design have one big advantage. They allow us to have a more detailed understanding of the relationship between the independent variable and the dependent variable. When we apply more than 2 manipulations of the independent variable, as we have seen here, we know not only the effectiveness of introducing a teaching method on achievement, but we also know which of the 4 teaching methods can have a better impact on student achievement. The third and final type of the randomized group designs is the matched group design. In a matched group design, the experimenter first selects a matching variable to see whether the different groups of subjects are equal on the matching variable. For instance, if the experimenter wants to know the effect of teaching methods, say 3 teaching methods A, B and C on academic achievement, then he knows that there is one variable which can possibly influence the relationship between the independent variable of teaching methods and the dependent variable of academic achievement. This variable may be intelligence. So he wants to know whether the different groups of subjects who are appearing for the experiment have an equal amount of intelligence or are balanced on this criteria. So he may give a pretest in the form of an intelligence test, and on the basis of the scores obtained, he may divide the subjects into various groups so that both the subjects are balanced out on the criteria of intelligence. Now there are 3 methods by which this kind of matching groups may be formed. The first involves matching by pairs. If you can see the slide, you will see that a number of intelligence scores of the subjects are obtained. In the matching by pairs method, you will see that there are certain subjects who obtain similar scores, say 75 and 75 or 70 and 70. And these pairs are isolated and one from each pair goes into each group. So thus there is a subject having the same intelligence level in each group, and thus the groups are equalized. A second form of matching would be on the basis of mean and standard deviation. When we cannot make exact pairs because people may not get exactly similar intelligence scores, we may use people who have similar means and similar standard deviations on the intelligence scores. We may group all those people together, and from that group we may randomly assign them into the various experimental groups. A third method of matching would involve the random blocks method. In the random blocks method, the subjects are divided into random blocks or groups depending upon the number of manipulations of the independent variable. In the example we just said, there are 3 manipulations, that is teaching method A, B and C. And so the random blocks will consist of 3 subjects. So a random sequence may be taken, say 2, 1, 3. So the first subject will go into the second group, the second subject will go into the first group, and the third subject will go into the third group. Another method of matching involves the method of counterbalancing order. Here again, the intelligence scores will be arranged in an ascending or descending sequence, and a random order may be developed. Say for example A, B, 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 A, C and so on. And the first subject will be assigned to condition A, the next 3 subjects to condition B, the third subject again to condition A, the fourth subject to condition C and so on. Yet another method of finding out matched pairs involves the block repetition method. In the block repetition method, again the intelligence scores of the subject will be arranged either in the ascending or the descending order, and the natural sequence will be followed, that is A, B and C. So the first subject goes to condition A, the second goes to condition B, the third goes to condition C and so on. Now one main criteria in the matched group design is to find out a matching variable which has a high degree of correlation with the dependent variable. Say for example, when we are studying achievement as the dependent variable, then intelligence would be a good matching variable because it has a high degree of impact on achievement. However, it is not always easy to find such a good matching variable having such a high correlation with the dependent variable. And if the experimenter is able to find such a good matching variable, and if the number of subjects is large, then he should surely go in for a matched group design because it provides to a great extent for the equivalence of groups. And when the number of subjects is high, then it compensates for the loss of the degrees of freedom because matched group designs involve lesser degrees of freedom as compared to randomized group designs. Now we come to the third type of between subjects design, that is the factorial design. Both randomized group designs and matched group designs allow for a number of manipulations of the independent variable, but we can study the effect of only one independent variable on the dependent variable. Say for example that we want to know the effect of two or more independent variables on the dependent variable. In such a scenario, we need to use the factorial design, because the factorial design allows us to use more than one independent variable and to analyze both the effects of the independent variable, any number of manipulations of it, and it also helps us to analyze both the independent effects of any number of manipulations of the independent variable, as also the interaction effects of the two or more independent variables used. If you have a look at the slide, you will see that in this experiment we are trying to see the impact of both noise and illumination as two independent variables on reading ability or the dependent variable. Both the independent variable of noise and the independent variable of illumination are manipulated in two ways, that is high noise condition and low noise condition, and high illumination condition and low illumination condition. So you know that there are four conditions which are created, and subjects will have to be assigned into four conditions, and this will help us to know both the independent effects of illumination and noise on reading ability, as well as to whether noise and illumination interact with each other to bring about changes in reading ability. Now this kind of design, where there are two independent variables and each of the variable is manipulated in two ways, is called the 2x2 factorial design, and hence there are four conditions. Now there may be several factorial designs. We can use a 3x2 factorial design, a 3x3 factorial design, a 3x3x3, or a 2x2x2 factorial design. For instance, in a 2x2x2 factorial design, there are three independent variables and each of these independent variables are manipulated in two ways. Or in a 3x3x3 factorial design, there are three independent variables and each of these variables is manipulated in three ways. Now there are two main advantages of using a factorial design. The first advantage is that we can know both the independent as well as the interaction effect of more than two independent variables, and this is something which a randomized design doesn't allow us to do, or even a matched group design doesn't allow us to do. So it both saves a lot of time, money, labor, and it involves a lot of economy. Also, a second advantage is that we can get a better insight both into the independent effects of more than two independent variables on the dependent variable, as also how these independent variables interact and produce interactive effects on the dependent variable. Now there are certain disadvantages also of a factorial design, and this is especially true when there are more than three independent variables and more than three manipulations of the independent variables. So the number of groups formed will be very large and the experiment will become so complex that the experimenter will want to go back to some kind of a simpler design. A second factor is that when there are such a large number of groups, it becomes difficult to select homogeneous subjects to fulfill each criteria and to be a part of each group. And sometimes when the treatment combinations are too many, due to a number of independent variables and a number of manipulations, some of these treatment combinations may actually be useless and may contribute little to the research. Now that we have seen what between subjects designs are, we come to the second form of designs, that is within subjects design. Now the main feature of the within subjects design is that the same subject or the same group of subjects serve under different manipulations or conditions of the experiment or of the independent variable. For example, if we want to study the efficacy of three teaching methods, teaching method A, B and C, on academic achievement using a within subjects design, the same subjects will be first taught by teaching method A and a test of achievement will be taken. Then they will be taught using teaching method B and again a test of achievement will be taken, and finally they will be taught with teaching method C, and yet again one more test of achievement will be taken to see whether there are differences in the achievement levels depending upon the type of teaching methods used. Now, use of within subjects design, as I mentioned earlier, are rare in psychology and they have some kind of advantages. Firstly, since the same group of subjects are participating under all the experimental conditions, the main criteria of equality of groups or randomly assigning subjects into different groups is actually something we do not need to deal with, and this becomes a big relief for the experimenter. Secondly, when an experiment involves detailed neurophysiological apparatus, say for example surgical procedures or electrodes, it is better to use the same subjects because it will be difficult to actually apply these complicated procedures to different groups of subjects. Thirdly, when the number of subjects is very small, it is better to use a within groups design because if we randomly divide them into different groups, then the groups will be very small. Also, if we want to see the subject's behavior over a long period of time, then or we want to apply a longitudinal design, then of course within subjects design becomes the only recourse. Only then can we see how the behavior of the subject varies with different levels of the independent variable across a period of time. Now, one major disadvantage of the within subjects design is the effect of practice and fatigue. For instance, students taught with teaching method A get some kind of practice and it may influence their achievement to some extent, and the practice or the information they have gained from teaching method A will carry over to the condition of teaching method B, and the information they have gained from teaching methods A and B will carry over to C, and hence the kind of academic achievement we see in response to teaching method C may not only be due to the teaching method C but also due to previous experiences on teaching methods A and B. Also, since the subjects are again and again appearing for achievement tests and going over teaching schedules, they may be fatigued, and any kind of changes in performance in teaching method C may be due to the fatigue of having to be part of repetitive experimental conditions. Now in this chapter, we will also be dealing with ex post facto designs, which are a special kind of quasi-experimental designs. Now, ex post facto designs are designs in which we cannot directly manipulate the independent variable, but still we want to see what kind of relationship exists between different characteristics, attributes or variables. And in psychology, many a time, because of our inability to manipulate a number of behavioral variables, we tend to use ex post facto designs. Now, there are two main kinds of ex post facto designs. The first is the correlational design. In a correlational design, we try to see the relationship between two variables or two characteristics which are already in existence in the population without trying to manipulate them in any way. Say for example, the experimenter wants to know the relationship between intelligence and problem solving. He may randomly draw a certain number of children from a school and will give them an intelligence test, getting a score, as you can see in the slide, of O1. He will also give them a test of problem solving, getting a score of O2. Then he will see the kind of relationship or correlation between O1 and O2, that is between the intelligence scores and the problem solving scores. Say for example, children with a high intelligence also have high problem solving scores. The researcher can say that there is a high correlation between intelligence. He can say that there is a significant positive correlation between intelligence and problem solving. On the other hand, if he finds that children with high intelligence have low problem solving capacities and those with low intelligence have high problem solving capacities, then he can say that there is a significant negative relationship between intelligence and problem solving. Or if he gets random results which indicate that intelligence and problem solving are not related, then he can say that there is zero correlation between the two variables. But one major limitation of correlational designs which we must remember is that cause and effect relationships cannot be established on the basis of a correlational design. Just because students with high intelligence also have high problem solving capacities, we cannot say that high problem solving is caused by high intelligence, because there may be a number of other factors involved also, such as the past experience of the students, the kind of family background they are coming from, and so on. And so we cannot say that intelligence is the factor causing the high problem solving ability. We can only say that there is a relationship between the two factors, and as intelligence increases, problem solving ability also increases. The second form of ex post facto design is the Criterion Group Design. In a Criterion Group Design, the experimenter tries to determine or ascertain what are the possible causes for a condition by selecting a group which has the condition and contrasting it with another group which doesn't have the condition. Let us take an example to elucidate this. For example, the investigator wants to find out what are the various characteristics or elements that influence creativity. So he may give a test of creativity to a number of students, and he may divide the students into two groups on the basis of the test results. say students who have a high creativity and another group of students who do not have such a high level of creativity. Then he will take the group of students who have a high level of creativity and try to determine the various factors in their environment. Say for example their attitudes, their values, the parental education, the kind of family they are in, what kind of schools they are in. They may conduct a number of structured interviews with teachers, parents and others, and then they can actually put up a picture saying that possibly the high levels of creativity in these students are caused by such a number of factors which differ from the conditions which are available to students having a low level of creativity. Thus, we saw in this lesson a number of experimental designs. First, we saw between subjects design and the three types of between subjects design, that is randomized group designs, matched group designs and factorial designs. We also saw within subjects design and its advantages and disadvantages. Finally, we saw what are ex post facto designs and two important types of ex post facto designs, that is correlational design and criterion group design. And finally, from this lesson, we have also tried to understand why it is absolutely essential for the researcher to have a research design or a blueprint of the experiment before he actually goes on and conducts the experiment.